Hi everyone, this is Suhas Mansingh from Cisco, India. I want to talk to you a little bit about networks, how they're evolving, and why do I see this as a time to rethink about the whole architecture that we're using for wireline networks, right? And I think the first thing that we need to realize is that more and more, uh, the value of the network and the services that can come on top of it is more and more we're realizing that they are really important for us, especially during the COVID times. We're actually seeing how everything kept on running because of the network. So we do realize that the network is really important. The reliability of the network architecture, the network design is important for our success in the internet generation as we move forward. As more and more new services are going to come up, there's going to be augmented reality, virtual reality, uh, remote medicine, many different kinds of services are possible. The bandwidth required is going to keep on going up in the network, which basically means we need to make sure the networks are resilient to the growth of the bandwidth. But how fast is the bandwidth growing? We all know it's growing, right? But if you look at it, bandwidth is actually growing exponentially. And most of us say, fine, we can manage that exponential growth. We know what the technology is and what it takes to do it. But humanly, it's very difficult to understand really what exponential growth is. There's an example story that's been told a long time ago is, the inventor of chess went to the king and, apparently a story in India. And the king said, I like the game. What do you want? I really like what you've invented. And the inventor said, I'll put 1 grain of rice on the first square. I'll put 2 on the second. And let's keep on doing that way until we reach the 64th square. Keep on doubling it all the way. And whatever is left there is all I need. Not much. And first, step of human comprehension, it doesn't look like a huge amount. And king said, okay, go ahead. And by the time they did it, they needed around 29 billion tons of rice, right? There's no way the kingdom had it, no way India had it. And the whole point here is the realization that human brain sometimes does not comprehend what exponential growth is. So now we're seeing this exponential growth, and we are probably quarter to a halfway between there on the chessboard. So although we are pushing the system hard, it's still working. But we're getting to doubling stage where everything is doubling over time, tripling over time, and the same architecture is not going to hold up. And we have to realize that, right? Now, for us to be successful to manage this growth, what has to happen is we should be able to carry that bandwidth. So in the networks, right? So first, let's see if it's possible to do that, right? And that's where technology has actually evolved to keep up with this growth. So if you look at the way technology has evolved, there's a law called Shannon's theorem, right? Shannon's theorem basically says what is the maximum amount of data that you can carry on any fiber or with the maximum capacity that can be carried on it. With the processing power that we have right now, we are getting close to the Shannon's limit on what we can carry. And the beauty of the processing power, though, the numbers, because of Moore's law, which basically says that the number of transistors double every 2 years and the cost halves, we are building chips which are more and more powerful, which are more and more small, actually, consume much less power. I mean, if you look at a 8086 that was built in 1979, 1980, the Intel processor, it had around 29,000 chips. And if you look at what we have right now, the M1 chip just came out on the Mac. It has about 16 billion transistors, right? From 29,000 to 16 billion in a span of a little over 40 years. So technology has been keeping pace. Bandwidth's been growing exponentially. Processing power has been growing exponentially. And that's what made this successful. Now, actually, we're getting to a stage where the technology is actually growing at a much higher pace. And we are able to carry, in fact, the chips that we have right now can actually carry this huge growth in bandwidth and more. So we are actually getting to the stage where the capacity for us to carry bandwidth is actually growing at or higher than the pace at which the bandwidth is growing, even when it's growing exponentially, right? And that's where, looking at these two things, we have to figure out how do we take the current networks, simplify them overall, and focus on the services that are run on top of it. The way we built the networks over time has been driven by evolution of technology slowly over time, right? Technologies, Ethernet evolved, IP, MPLS, segment routing, WDM technologies evolved, the ROADMs came in. We had TDM that was evolving. TDM moved, and as we moved to gig and above, and as we saw that more and more traffic that's being carried is going to be around video and packet, OTN started evolving, and each one of these technologies continued to evolve throughout years. And the networks were built on what was optimal for whichever technology that was growing at that time. So there's OTN technologies, that OTN switching that's used at a lot of places around access. There's DWDM switching used in the transport layer quite often because, switching at the light seemed more efficient. Over time, if you look at it, the technology as far as packet switching or technology, which basically decides what goes where, the one that's winning there is the IP technology, right? So, and that can be seen very clearly. If you look at ASIC that can switch IP or packet versus an AC that can switch, say, OTN, we have 10 to 12 terabit of capacity ASICs that are coming in, and on OTN you'll see 1 to 2 terabit, because it's not possible, it's because that's the direction that's going in. So all the multiple technologies evolved over time. The technology that won, or that technology that is the leader, is going to be around IP as far as the switching and the running of the data on a network is concerned. The second thing we need to do is we need to pump as much traffic as possible into these fibers. And as I told you, we are reaching close to the Shannon's limit. We're actually doing very well. Some of the pluggables that come in, which can carry up to 400 gig or 800 gig or tera, are actually this small, right? So we know the technology that's winning as far as the network, switching and routing is concerned. And we know the technology that's right to pump as much traffic as possible into a fiber. And we put them together to get what we call as IP and WDM. I think everything else has to be reduced over time, because if we build a flat network just using these two technologies, the simplicity overcomes the suboptimal maybe functionality at some places, right? The way we're used to building networks is, suppose I had to go from Agra to Delhi, a small gully in Agra to a small gully in Chandni Chowk. Typically the way, we would go is we take a car from end to end because we want to reach from here to there. If you have to build each layer optimally, inside the gully of Agra, you probably need to take a rickshaw. Outside the roads are bad, maybe take a tractor. As you go down to the main highway, you can take a nice car. As you reach Delhi and get into the traffic, you need a smaller car to go through the traffic. And as you get nearer, say, to Chandni Chowk, where you need to get to a rickshaw again. Now that's optimized each layer very well. And if you go to the guy who's going within Agra, is going to say, yeah, rickshaw is the right way to get out of it. Your car is going to take much longer. Go on the highway, take a nice, smart, fast car, big, nice, comfortable. That's the right way to go. Go inside the city of Delhi, take a smaller car. You can maneuver through traffic. Go inside Chandni Chowk. It's right to take a rickshaw here because you can't manage with a car there. But we know end to end, it's better to just take one vehicle, go from one end to the other end. So sometimes just a good enough technology is good enough because the focus is on a bigger picture. And that's where we have reached with the networks. I think simplifying, converging networks to one layer of IP and WDM while focusing on services on top of it, which are going to be revenue generating, is the direction that we need to move as we move forward, right? So my goal here is to make you realize, what's happening in the world. Technology is keeping up. We are able to carry a huge amount of bandwidth, even as the bandwidth grows exponentially. But that does bring into the point that we cannot continue with the current architecture. But the current architectures are not going to scale. We need to use the architectures which have scaled, keeping up with the growth of bandwidth, which are both IP, as you can see with the chips switching more and more, 10 terabit and 15 terabit switches that are coming in, and coherent technology, which is again have kept up with the growth in bandwidth. These two technologies combined with an integrated network, flat network, our end-to-end story. So networks. So now you can focus more on what services you can provide to our customers, what AR, VR, what low latency services are possible. instead of trying to optimize each layer of the network. So that's the focus of this. I think technology is in a very interesting phase. I think we need to accept where it's heading and move towards it. So thank you, everyone. Hope you enjoyed this talk.